Okay, so this next small unit deals with inequalities that exist in triangles. And the first section here is the inequalities for the sides and the angles of a triangle. Um, we're comparing the angles of a triangle, we're comparing the sides of a triangle. So if we think of something like a scalene triangle, all the angles are different, all the sides are different, and we're just making comparisons. This one's bigger, this one's smaller. So let's take a look at it. So it's really important to realize or to remember um, the properties of triangles, where if all three angles are congruent, then all three sides are congruent. Our focus is going to be mostly on scalene triangles in this section, where no angles are congruent, so no sides are congruent. They're all different measurements. And our goal is going to be to identify the biggest, the smallest, list them in order, even if we don't know their real measurements, just by applying the properties of triangles. So let's jump right into it. Textbook language, it's a little clunky. If one side is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the smaller side. Um, you can certainly read over that. Obviously, our goal here is to simplify things. So let's try to keep it simple. In a triangle, the biggest angle is opposite the biggest side. The smallest angle is opposite the smallest side, right? So we create relationships among angles and sides that are opposite of each other. If we can label, think about the idea that there's three sides and they're all different measurements. So maybe we can label them small, medium, and large, and the angles as well. If they're all different, then I like to label them small, medium, and large. And then I can put them in whatever order I have to. But I'm going to use the simple approach that the biggest angle is opposite the biggest side, the smallest angle is opposite the smallest side. Obviously, the medium is opposite the medium. So we can do this in whatever order we have to. So let's go through the exercise and just understand what we're saying here. And we've seen this before. The biggest angle, the 80, is opposite the biggest side, MC. I'm sorry, AC. AC. The smallest angle is a 40, and we draw an arrow out of it, and it points to the small side, or the short side, AB. And we're left with the medium. So personally, I tend to do them in that order. The biggest, the smallest, and then the leftover is the medium. But whatever works for you as an individual. And then we can list them in whatever order we have to. So again, angles and sides that are opposite of each other is a really important relationship in triangles. If we can identify them and label them, then we can list them in whatever order we need to. So let's take a look at it. Okay. We can reverse that process. If we know the sides, we can predict the angles. And again, we're using the same approach here. Our measurements are 9, 11, and 16. So 16 is the longest side. Opposite that is the largest angle. So the biggest angle is opposite the biggest side. Angle B is the largest. We can say 9 is the smallest side, and opposite that is the smallest angle, angle C. So you can see how I'm just labeling things small, medium, and large. So let's apply this. Now, the first thing we notice is that we're missing an angle. We have to find that missing angle. So remember, all the angles add up to 180. So we don't ever want to forget that. 30 plus 60 plus x equals 180. And we know that our missing angle here is 90. Now, what I want to do is the biggest angle is 90. So this is the large side right across from it. The smallest, right? So the largest angle is opposite the largest side. The smallest angle, draw an arrow out of it, is going to point to the smallest side, and now I'm left with my medium. We're asked to list the sides from shortest to longest. So we're going to list them small, medium, large. The small is AC. The medium we labeled AB. And the largest side is CB. So we're just putting them in order. We don't know their measurements. We have no way of figuring out their measurements with the information we have, but we do know how they compare or relate to each other. Once we label it, put it in whatever order the question asks, smallest to longest, increasing measure, decreasing, ascending, descending, whatever vocabulary terminology they use, interpret that, and then list them in order. Here we're asked to list the angles. Well, we know the sides. We're going to take the same exact approach from a minute ago. The biggest angle is opposite the biggest side. So this is my biggest side. So this is my largest or biggest angle. My smallest side is 12. Opposite that is my small angle, which means the last one is the medium. So again, I'm going to read the question. It says list the angles, largest to smallest. So I do have to be attentive to that. Now we're going to go large, medium, small. Well, the largest angle is angle A. The medium is angle C. And the smallest is angle B. And be careful how you name angles. In this case, one letter is acceptable. In some cases, it's not. So we do have to be careful of that. Let's apply it in another example here. Here we don't know any of the angles. We're given algebra, but we don't have any angle measurements. So the first thing we're going to have to do is figure out these angles. So we're going to add up our angles. 4x minus 15 plus 2x plus 10 plus x plus 10, and we know that the total has to be 180. The three angles of a triangle will always add to 180. So let's work this out. We've got 4, 6, 7x and plus 5 equals 180. 7x equals 175 and x equals 25. Well, x is 25, but we need angle measurement, so we're going to plug that back in. So for angle A, we've got 4 times 25 is 100 minus 15. So this is an 85-degree angle. Let me rewrite that a little neater. 85 degrees. Angle B looks like 35 degrees, and angle C 60 degrees. Now I might want to add those up, make sure that they really do add to 180, just to make sure. Now I know my real angles, but I was asked to list the sides. So the biggest angle is opposite the biggest side. The smallest angle is opposite the smallest side. And the last one has to be the medium. We're asked to list it from shortest segment side to longest side. So my smallest or shortest side is AC. Next is AB. And finally, my longest side is CB. So I had to find those angle measurements first. List the angles. So we don't know the angles here. We don't even need to know the sides. Again, they didn't give us numbers. They gave us some algebra, but they did give us some important information. The perimeter is 154. Well, when we add the sides, that equals the perimeter. So 6x minus 4 plus 5x plus 4x plus 8 equals 154. So again, we're adding the three sides to perimeter. Just going to give a little room here. Let's see what we have. We have 15x plus 4 equals 154. 15x equals 150. And x equals 10. We need to take that 10, plug it back in. So 5 times 10 is 50. 6 times 10 is 60 minus 4 for 56. And 4 times 10 plus 8 is 48. Again, we may want to add those up, make sure that it does total 154, so we know we solved it correctly. We're asked to list the angles from largest to smallest. So again, the biggest angle is opposite the biggest side. If 56 is the biggest side, then angle B is the largest angle. And we can work our way down from there. Large, medium, small. Again, my approach for consistency is the biggest angle is opposite the biggest side. The smallest angle is opposite the smallest side. And the last one has to be my medium. You can do them in order, large, medium, small, or small, medium, large. You can do it whatever order works for you. You just need a consistent, successful approach. We're listing the angles from largest to smallest. So in this case, it looks like angle B is the largest, angle A is the medium, and angle C is the smallest. So in a scalene triangle, the biggest angle is opposite the biggest side, the smallest angle is opposite the smallest side, and we can infer the measurements. We might not know the actual angle measurements or side measurements, but we can certainly infer which one is bigger, which one is smaller, and list them in a comparative order. We can write this as an inequality as well. Since we're going largest to smallest, we can say angle B is greater than angle A, which is greater than angle C. So remember from Algebra 1, we can write a compound inequality. We are expected to maintain those algebraic skills. Now, let's apply this to a little bit more complex picture. So here we have two triangles connected to each other. Well, we're still going to start out working on each triangle independently. So I'm going to label each triangle small, medium, and large. In fact, the first question says work on triangle ABC. So in the top triangle, triangle ABC, 75 is the largest angle. Across from that is the largest side. I'll label my small and my medium. So now the sides of triangle ABC from shortest to longest are CB, AB, and AC. Now we're asked to do the same thing in the bottom triangle, triangle DBC. So DBC, the biggest angle is 85. Opposite that is the biggest side. So the largest angle is opposite the largest side. Opposite the 45 is the smallest side and the medium. So for that triangle, again, shortest to longest, BD, CD, and CB. And all of these should have segment bars. So we've been able to do each triangle independently. Now, the follow-up question for this, in fact, You can see my labeling in the next slide. The follow-up question for this, now that we've got each triangle labeled, is name the longest segment in the figure. So longest, we're looking for something listed or labeled as large or long. Notice the center, CB. It's the longest of one triangle, but it's the shortest of the other. So it's neither. Whenever these are labeled differently, they cancel out. And we're only left with one answer. I think about this as like small, medium, and large drinks. And, whatever. One is Burger King, one is McDonald's. So the largest cup at Burger King is the smallest cup at McDonald's, which means they have stuff that's even bigger. Or whatever analogy works for you. Small, medium, and large ice creams, comparing Dairy Queen to Carvel. Whatever analogy works for you. The segment CB is the longest from one triangle, but it is the shortest of the other triangle, which means the other triangle has things that are bigger. Whenever that shared segment is labeled two different things, they effectively cancel each other out. So in this figure, the longest is AC. The shortest is BD. The two others are somewhere in between, but right now we would have to do a little extra work to compare them. We certainly can make that comparison. But the point here is the shared segment, if it's labeled different things, it kind of cancels itself out. And we kind of see that explanation here. In this case, the longest segment is AC and the shortest segment is BD. Okay, just for a little written out explanation. So let's try that in this question. We're asked to identify the longest side of the entire figure. Well, we have to do each triangle separately and then make an overall comparison. So label the first triangle, small, medium, large, label the second triangle, small, medium, and large, and then we make our overall comparison. In our first triangle, AB is the longest, BD is the shortest, and then medium. Looking only in the second triangle, BC is the longest, AC is the shortest, and the medium. Now we can look at the middle of the triangle, the shared segment, and since it is labeled two different things, they kind of cancel each other out. And the longest side of the whole figure, we only have one thing labeled L at this point, and it is BC. So again, the longest of triangle 1 is only the medium of triangle 2, which means triangle 2 has something bigger, larger, longer. And that's the skill that we're applying here. We're just making these comparisons by labeling things small, medium, and large, and then doing a general overall analysis. All right, let's try one more here. Here we're asked to identify the shortest side of the whole figure. So we're going to label each triangle separately and then make our comparisons. So I'm going to start on the bottom triangle, the large, the small, and the medium. Now we can already see from the picture, the largest of the bottom triangle is not the biggest segment in this whole picture. In the top triangle, we have the large, the small, and the medium. Again, we can see right in the middle our shared silicon CD. It's labeled two different things. So it's not the shortest of the whole picture. It's not the largest of the whole picture. We are asked for the shortest of the entire shape. And in this case, our answer is CB. CB or BC, whichever way is fine. Okay, so inequalities among the angles and sides of a triangle and even of a figure made up of multiple triangles. All right, let's do some practice with it and we'll come back to more inequality work.